Hindustan Institute of Technology. Department of Aeronautical Engineering. 22AE521 Aero Engine Maintenance and Repair. Presented by Mr. V. Ganesan. AP/Aero. Unit I. Piston engines. What is piston engine? A reciprocating engine, more often known as a piston engine, is a heat engine that uses one or more reciprocating pistons to convert high temperature and high pressure into a rotating motion. The two primary reciprocating engine designs are the spark ignition, the compression ignition. Components in a reciprocating engine: the cylinders, crankcase, accessory housing, the intake/exhaust valves, spark plugs. Pistons are located in the cylinders. The crankshaft and connecting rods are located in the crankcase. The magnetos are normally located on the engine accessory housing. Engines further classified as: based on cylinder arrangement with respect to the crankshaft, based on operating cycle, based on method of cooling, cylinder arrangement with respect to the crankshaft, inline engine, radial engine, opposed engine, V-type engine, operating cycle, method of cooling, air cooling, liquid cooling. Carburetor systems. Mixes the fuel and air in the carburetor before this mixture enters the intake manifold. Primarily used in small aircraft piston engines. Aircraft carburetors are separated into two categories: float-type carburetor, small aircrafts; pressure-type carburetors, large aircrafts. Float-type carburetors. A float-type carburetor is a device that mixes air and fuel in the right amount before sending it to the engine cylinders. It is used in many small aircraft like the Cessna 150 or Piper Cub. Float-type carburetors, complete with idling, accelerating, mixture control, idle cutoff, and power enrichment systems, are the most common of the two carburetor types. Main parts and their functions. Float chamber, a bowl that stores fuel. The float, like in a toilet tank, rises and falls with fuel level, controlling a needle valve to keep the level constant. Venturi, a narrowed section in the air passage that increases air speed and decreases pressure. Fuel discharge nozzle, located in the venturi, it draws fuel from the float chamber due to low pressure. Throttle valve, controls the amount of air-fuel mixture entering the engine, thus controlling engine power. Mixture control, adjusts the ratio of fuel to air, important for altitude compensation. Idle and main fuel circuits, provide correct fuel delivery at low and high engine power settings. Operation. In the operation of the float-type carburetor system, the outside air first flows through an air filter, usually located at an air intake in the front part of the engine cowling. This filtered air flows into the carburetor and through a venturi, a narrow throat in the carburetor. When the air flows through the venturi, a low-pressure area is created that forces the fuel to flow through a main fuel jet located at the throat. The fuel then flows into the airstream where it is mixed with the flowing air. The fuel-air mixture is then drawn through the intake manifold and into the combustion chambers where it is ignited. Disadvantages. Can form ice easily, especially in cold or wet air, which may cause engine to stop. Wastes fuel, often gives more fuel than needed, rich mixture. Needs manual adjustment, pilot must adjust mixture at different altitudes. Fuel may not go equally to all cylinders, causes rough running. Float can get stuck, leads to too much or too little fuel. Slow to respond, engine reacts slowly when throttle is changed. Doesn't work upside down, not good for stunt or aerobatic flying. More pollution, produces more smoke and unburned fuel.